Yeah, welcome to Electoral Research Institute of Technology. My name is Yakub Mohammed, and I'll be doing the third video on Afro Uno library. Today, we'll be looking at how we can actually use the library to drive a 20x4 LCD. As you can see, I've set up my LCD. This is a 20x4 LCD, and I've connected my LCD in 4-bit mode, meaning that D0 to D4 will be connected to ground, and D0 to D3 will be connected to ground, while D4 to D7 will be connected to my MCU. So like I said, this is a 4x20 LCD, and I will be using our Afro Uno library to drive it. I've already created the project. I'm trying to make the video very short, so I already created the project and I've added the lines of code. Just for simplicity, I'll go through the lines of code, then I'll explain each of them. So let's just go to the top. So all you need to do is create a new project. Once you create a new project, then you can empty the project, the .cc file. Then you can actually add your code yourself. So as you can see, I've added the HSE value, which will always do depending on what crystal you're using on your MCU. The first 3 lines of code, which is line 33 to 35, as you can see on my screen, line 32 to 35 are actually added by default. You leave them the way they are. Then they define using Stm32. I did say in our last video that if you are using our library, you will need to include that definition. That's to tell the library that you will be using the Stm32 part of the library. The next line of code is the using F1. F1 is simply saying that I will be compiling this code for the F1 series. There are different versions of series, the Stm32 in the market. I think I've only been able to program 2 of them, which is the F1 series and the F4 series. So the next line of code is actually the pin definition for the LCD. As you can see, the first line definition is LCD RS. RS means register select, and I'll be connecting that pin to port A bit 7. LCD enable will be connected to port A bit 6. The LCD D7 will be connected to port A bit 2. So these lines of code are actually required to tell the compiler these are the pin you'll be using. The other thing you still need to define is the direction of the pins. The LCD RS direction is actually in PA7, which is the same thing as A7, which is the same thing as the LCD RS pin. I did this definition because this library was actually I was formerly using this library for AVR. AVR requires you to specify its direction. So I just modified the code so you can actually use it for the Stm32. So the next line of code is actually the using LCD, using port. I remember I did say in our last video that whether or not, irrespective of what you're designing or probably what you are going to be coding, you would almost always use your port. So that will always be added in your code using port. There's never a time you write a program without using the port. So it's not possible to use this library without using port. So in almost all cases, you will have to have that definition there using port. The next line is using LCD. So because we're using the LCD library, we need to define it using LCD. If you don't define it, it means that you cannot use the library. So once that is defined, you're good to go. The next line of code is to now add the Afro Uno library, which we did in our last video. And I said in our library is actually in our C folder, and the path is given here, #include. You include whatever part of your library. If it's on your desktop, you just need to specify your file path. The next is actually defining the LCD. It's actually a class. I will look at that LCD library when I go through this program. I was supposed to even look at that first, but let's just continue. Once I'm done, I will look at the library. So this is saying that we'll be using an LCD display. LCD is actually a class. So I'm going to be creating a type called display, DISP, and it's going to be a 20x4 type. If I'm going to be using a 16x2, I'll just change this one, the 20x4 to 16x2. So this is saying that I want to use the LCD part, and it's going to be a 20x4 LCD. Okay, next is I have created a variable and these are just strings that I really want to show on the display. So I've defined them as row 0 up to row 4, and I've set different parameters, sorry, row 0 to row 3, and I've set them to different string. So next, I remember I said we should always enable our 6 tick if we want to be using delay. So the first line of code is enable 6 tick, 6 tick macros. So this line of code actually allows me to use my delay function. Sorry, my video is not too clear. I'm trying to adjust. Okay. All right. The next line of code is saying clock, enable clock port A. Like I said, I've connected my LCD to port A, so I'll need to enable the clock port A. So let me just deselect this. Okay. So the next line is to initialize our display. So the first line is saying display init. Display init is saying initialize your LCD. Then whenever I initialize my LCD, I would want to return the cursor, assuming I don't know what the cursor position is. So the next line of code is send command LCD return home. At that point, the cursor will be returned to home, so that when you start writing to the LCD, you are sure what position you're writing to. The next line of codes are actually the display.write text. 00 means row 0, column 0. 10 means row 1, column 0. 20 means row 2, column 0. 30 means row 3, column 0. So like I said, we are using a 20 by 4. So that's why we have 4 different rows. And at this point, you're actually going to be writing the string LCD row 0, LCD row 1, LCD row 2, and LCD row 3 to it. Once that is done, we'll want to return cursor back home. So that's why you have the next line of code as display.send command LCD command LCD return home. Of course, after that, we want to delay 3 seconds so that we can actually see the first information we are written to the LCD on our LCD. Then the next line is still writing text, but in this case, instead of writing arrays to it, we want to actually write the string. I just want to show us how we can actually write a variable that is saved in we want to write an information that is saved in the variable, or an information that is saved in the program code. So like you see, after that, we are writing the electrohive Nigeria, www.learning.com, of course, a phone number there to the LCD. These are the two ways you can actually write text to it. So if we compile this code and program, we should see all of this thing we have programmed. But before we do that, I did say that I want us to look at the LCD library itself and see what we can actually do with the library. I already have opened the library. In your own case, you need to go to your file path, which is the Stm32 library. Once you open that folder, you see a file called the lcd.h. That is supposed to be the LCD library. So I'll just open it and look at it. Take it up. Just want to look at what we can do with the LCD. Basically, we just look at what we can do with the LCD. I'm going to be looking at the class itself, the LCD class. So you can see that it's actually a C++ code. For those of us who are familiar with C++, we know what classes are. If you are not, for now, just learn how to use it. Then subsequently, you can actually try to understand what each line is actually saying. So the first LCD, each time you create a new type, you use the word LCD. You're going to specify the column and you're going to specify the row. So let's go back to our main program. We saw where we display the LCD display. We are going to specify the column. We're going to specify the column, and we're going to specify the numbers of rows that the LCD have. In this case, it's what 20 columns by 4 rows. So let's go back to the LCD. So like I said, the first guy actually allows us to define the LCD type that we're going to be using. Next, initialize the LCD init. You just need to call the init function. Once you call the init function, it automatically initialize the LCD for us. So some of the things that we can do with the library is that we can actually write character to the LCD. Character, row, column, and the character you're writing. So if I specify the row here, the column here, and I'll send the character. If I do this, I'm going to have one character displayed to the LCD. The next is write text. Write text means that if I want to write a string to the LCD, as you can see, you still need to specify the row, the column where you want the information to be put, then of course the string you're trying to write. Then the next function is write ASCII. ASCII is actually, you can send a parameter as in terms in binary form, and it can actually display it in ASCII form for you. Let's say the binary number for A is 65. You can just send 65 to it. Instead of displaying 65, displays A. So you display the ASCII character they are sending. The next is display decimal. You know, like we know, decimals are not ASCII. They are not ASCII in nature. So if you send the physical number 65 might not be displayed as an ASCII value. But in this case, if you want to print the number 65 the way it is, you can actually call this write function, write this decimal, specify the row you want to put it, the column you want to put it, and the number itself. So you can actually write 134, 136 as the case may be. Ordinarily, if you send 136 to the LCD does not understand binary number. But if you really want to display them the way you have them, like in binary form, like in decimal form, then you should use the function called the write decimal. Write decimal will just put it the way it is. The next line is writing hex. Writing hex means that you want to write the hexadecimal of a particular number to it, rather than just having to format yourself. You just call the function called write hex. It does that for you. The next line is to clear line. You can actually clear an LCD line. The lines can be line 1, line 0 to line 3 in our own case, because we are using what? A 20 by 4 LCD. So if you are using the 16 by 2, it means that you're going to be having just 2 lines, which is line 0 and line 1. But like I said, the clear line allows you to clear the entire line of your LCD. Clears the entire display. Send command. If you want to send command, and there are different kind of command you can actually send depending on what you want to do with the command. You can scroll the display. Direction can either be 0 or 1. Direction can either be left L or R. If you send a capital L or small l, then it means that you're going to be scrolling your display to the left. If you want to display to right, you send a capital R or a small r. Then you can actually send a 0 or 1. 0 means left, 1 means right. Then of course the number of positions you want to shift your display to. You want to scroll your display. Say you want to display your display by 1 position, you put 1. By 2 position, you put 2. By 3 position, you put 3. Then of course the last two functions actually write RAM and position your cursor. Let's say you can actually, if you want to write to position 6, you can actually set your position and write a value there. You can actually set your position yourself. The other functions are private. If you understand C++, you know that you cannot use these functions. These are functions that are used internal to the FCD library. So like I said, the library allows drive a 16 by 2 or a 16 by 2 or a 20 by 4. These are the two LCD that have actually tested it. Of course, if you have time, you want to modify the program for us, you can actually add your own LCD and maybe send us a code on how you have done that. So the next is for us to actually test this program. We just need to cross-check, go through the code again. So I'll just go through it once again. So you can see that's the code. I'll compile this code and send to our LCD. So I'll just build the project. So like I said, remember we're using a 20 by 4. So like I said, I've already set up the board just to reduce my video time. And the pins are connected to port A. The pin numbers is actually shown in our software. While the program is compiling, you can just look at the pin position. I know some persons will be saying I should give you circuit diagram. I don't really need to do that. You can actually look at the program code and understand where and which pin is connected to what. The LCD ROS pin is connected to A7. The EM pin is connected to A6. The D4 is connected to A5. The D5 is connected to A4. The D6 is connected to A3, and of course the D7 is connected to what? B2. Once you have all this information, you can actually wire your LCD the way it's supposed to be. So it has finished compiling. I would start the loader depending on what programmer you're using. I'm using an Stm32f103 programmer, and I'm using an XT-Link. So you can actually be using, let's say, there are other softwares you can use to program the XTM32, and of course there are other hardwares. So I'm using XT-Link. I'll just go to XT-Link. Okay, I'll just reset and connect. Okay, connected. So I'll go to load the program code. Okay, that's it. LED blinker. Sorry, I'm using the same LED blinker code. I didn't have to rewrite it all over again. So what I did was just to remove the LED blinker code, then write my program inside. So don't bother about what the name is saying. Just open it.